So this is a quick demonstration of the different models of the hydrogen atom. So we have the different models on the left here. We have different types of light. We're going to have a box with a hydrogen atom in there. We're going to have three different type of things. We'll be looking at electrons moving around. We'll see the protons and neutrons in the nucleus. So we turn on light. So these are different. We're going to slow it down a little bit. I guess we're not. So we're going to see that these are a bunch of different photons of different energy, but everything bounces off the billiard ball. So no interaction between light and the hydrogen atom. If we move to the plum pudding model, we can see that certain photons are absorbed by the electron, emission of photons when it stops moving, but the electron is just kind of in this mass. The classical system, solar system, basically, we'll do that one again. That goes round and round and then collides with the nucleus, and so that's it for that Bohr model. This one, we'll see it. This electron is going around here, and then it gets excited, and then see a photon went back to the ground state. Oh, there it is. Now it's back down. Where is it now? There it is, and then it went back down. So it's what I want you to get from here is that it moves between these different orbitals. It's never in between, so it can kind of orbit around, absorb a photon to go up, and emit a photon to go down. And this is the model we tend to teach a lot, just because it's the easy to visualize, and it pretty much summarizes most of the math that we'll have you do for the hydrogen atom, which is the simplest atom because it only has one electron. De Broglie used waves. This is a standing wave, so it kind of looks funny. Still using the Bohr model, but now there's no more electron as a particle. It's treating an electron like a wave, which is what De Broglie postulated. So this is what it looks like in practice. And then Schrodinger's wave equation, now electrons are probability densities, where the brighter parts are more likely, darker parts are less likely to find an electron, where these different shadings or different orbitals that have the distance from the nucleus is farther and farther for the higher energy orbitals. So this is a nice little visualization of how the different models of hydrogen atom have progressed, where from the Bohr, De Broglie, and Schrodinger are all quantum models, where the first three are all classical mechanic models. So this simulation is not HTML5. It takes a little bit to get it running with a Java. So I just decided to make a video instead of having you guys try to do all that footwork. So hope you enjoyed it. You can do a couple other things, like you can show where the different electrons are being absorbed. You can change the light so that you can only have certain photons. You can play around a little bit, but and then you can kind of see things that we won't really talk about, but pretty cool sim. All right, hope you like it.